Now you have this 12. It doesn't take much if the low force is coming down this way, and more so on the outside over here, on the edge of the deck. You have some of the deck wanting to grip and hold on as the shear is trying to create into space, if you will, out through the blister, somewhat, and also the blister wanting to hold on to the edge of the deck. The blister and the deck being built together, the shear forces coming down there want to hold on to the edge of the deck. So we have the motion, the shear forces wanting to rip from here over. Also we have the shear force down here, so our zone of shear force is limited into here, all downwards of 12. That's nice how you guys can see it in that profile. And that profile would give you the pocket, the removal from the pocket. And then from this side, from the bottom, from the back, from the rear end of this, from the rear end of 12 now, looking at 12, you would see those forces also create those outward effect. Remember, it's 10 inches of concrete out here with the dead load. To get the dead load, I need this dead load to no longer be supported by the clamp force of B. Because B is holding this section together now. It's got a clamp force inside here. Don't think of the entire thing, but this section here is being held together by B, rod B. Not by the cracks, but B is still holding it with the blister. And the blister back here, this concrete, is a giant washer. It's a giant washer made of concrete holding this section together. And the rod was only detensioned, but the nut remained in place. Just like you have over here with the small tension cracks, you now have a large tension cracks in number 11. Once this was detensioned, the large tension cracks appeared. The large tension cracks cannot appear if you don't get a downward motion or an outward motion, but the outward motion would be a different crack altogether. So to get a downward motion, we talk about this shearing, as results of shearing here, which we know it cracked like hell. We saw it, the statement is right after detention. So this is not magical sliding at this time, because to do that, you would have, you're sliding to, I don't know what exactly sliding would need to take place to cause the shearing. I know what would, to cause that shearing, that shear break or shear punch, however you like to look at it. I know what it would take to create that in this design. We know that 100% because it was created. You just have to accept the data. Detensioning, B, created that shear force, that dropping down force. A is still in the deck as it stands. It stops a buckling of this if you were to leave it totally in place. But it was detensioned, as we're informed to believe, in an even ratio of 50 kips per cycle, per revolution. So when that was done, this no longer was acting in capacity. This all changes. It is no longer sharing out. It's no longer being, the loads are no longer being restricted, pulled over to here. We knew this bridge worked to some capacity in the staging area, which I call the impound. The staging area, and I'm trying to get away from that, I guess. The staging area, it held for 40 days and 40 nights. It was 30-something days, right? So it held there because of the clamping force. It held there possibly because they had, this was the stage formed up where they still had reinforcement under 12 and specifically under that last 10 inches. And it held there because A and B and number 11 were in place. The idiots, and I'm not even taking liberty, I'm just calling it for what they are, do not know the difference between a tension or a compressive break in concrete. They do not know what it looks like. That's why they can't evaluate what they're looking at when they're looking at these cracks. To get this crack here, they have it as detensioning, slid this across. Detensioning, slid this across, creating this break. This break here was spoken of before detensioning. It was identified inside the impound, the staging area. To get this, you're going to have this deck here go downwards. Or you're going to have this whole triangle up here go like that, crown up, creating a hinge effect, pushing 12 outwards like that, identifying itself by pushing outwards to some degree to get the reveal of the crack opening at this chamfer, this 8-inch chamfer. Now, can you get it by the two materials compressing, which you compress in here, and this not compressing, a shearing right here? Could that be a shear? Looking at the cracks, they don't appear to be shear, they appear to be open. That is, if I could draw the crack, here's the base right here, and I draw up here, and then watch me exaggerate, I'm taking liberty, and I draw over here. It's open here and closed here. If it was shearing taking place, that would imply that the bottom chamfer would have to be anchored to the deck, and that magically the forces created here are compressing this concrete, literally compressing it, making it smaller like a sponge, making it smaller. And this was not made smaller, and that's where you get your break. Or they have it magically that the deck is getting smaller, but not the outside section of the deck. It's just ridiculous in this form of thinking. It would identify, if you try to make concrete smaller, you're going to get a compressive break. And that's going to look like a buckling effect. You're going to get, however, the member scale, the ratio, however, it will identify itself at that scale. That's not that. You also get the same type of cracking down the other end of the deck when they post tension number 2. Similar cracking, and the corresponding member would be number 3, I believe. So this means that I think 2 and 11, and the combination of both of them, had a camber effect when they caused this retraction. When they did their retraction, somehow they had a camber effect on this structure, which should have been identified. You could have done that with simple straight strings. 175-foot of string, of course, would not be good. You can do it. You could have done it with surveying. You could have looked at your scaffolding, knowing that your scaffolding's been, before post tensioning, was coming in contact with your entire scaffolding section, and now it does not. The odd thing is what forces could create this camber? Looking at it as a triangle, this would put an anchor here. And if you only look at B, if you look at A and B as doing this, so this is A and this is B. If I could do this,